Okay, so today we're going to be talking about the factor theorem and the rational root test, or the rational root theorem as well. And then we're also going to do a little bit of synthetic division. All three of these things are used: factor theorem, rational root theorem, and synthetic division. They're all used to factor large polynomials. Alright? And so what I'm going to do is I'm going to go through the process of using all three of these to find the factors of this polynomial. Alright? And so you begin. We actually begin with the rational root theorem. The rational root theorem goes like this. What you do is you look at the constant number right here and the coefficient, lead coefficient. The constant number is 2, the lead coefficient is 6, and you write these down in a fraction. 2/6. This is the numerator, this is the denominator. Then what you do is you take 2/6 and you start listing all of the factors of this. So the factors of 2 are 1 and 2. Remember that a factor is something that you can multiply with another number to get that number. So the only thing I can multiply with 2 is 1 to get 2, 1 times 2 to get 2, and 2 times 1 to get 2. Anyway, there we have that. The factors of 6 are 1 and 6, and then also 2 and 3. Now what you do is you take combinations of these to figure out what are your possible factors. So rather than just trying a bunch of different numbers, you can narrow down which ones are actual possibilities by taking combinations of these. So the combinations work like this. One of them is 1/6. Okay? Another one is 1/2. Another one is 1/3. And then another one, I forgot, 1/1, which 1/1 is just 1. Then I've got 2/1, which is 2. 2/6. 2/6, or 2/6, is actually equal to 1/3. So I won't list 2/6 because I've already listed 1/3. So I've done 2/1. 2/6 we already decided is equal to 1/3. 2/2 is actually equal to 1, so I won't list that. And 2/3, 2/3. So these are my possible factors, actually, of this polynomial. So it's narrowed down to 1, 2, 3, 4, 5, 6 possibilities. It's actually 12 possibilities, because I also have a -1/6 as a possibility, a -1/2 is a possibility, a -1/3 is a possibility, a -1 and a -2 and a -2/3. These are all of my possibilities, a total of 12. Now, that is the rational root theorem. So you begin factoring a polynomial by listing the constant term, 2, and then the coefficient, 6. Then you list the factors of 2 and the factors of 6. Then you take combinations, 1/6, 1/2, 1/3, 1/1, and so forth. And you take the negative values as well. That is the rational root theorem. Okay? That we just used. Now we're going to use the factor theorem. Factor theorem says that some particular value is a factor if I can evaluate that. If I can evaluate the polynomial at the number and I get a 0. So let me try. I'll just start with 1/6 here. Actually, no, what I usually like to try and start with the number 1 or the number 2, okay, just because they're easier. In this case, I'll start with the number 2, all right, and then I'll go number 1 next, and then I'll go -1, and then maybe -2. Start with the whole numbers, easier, and then just kind of get it done that way, and you can maybe in the end avoid having to use these fractions. Okay, so now what I'm doing is you search for a factor. And how do I do that? I evaluate the polynomial. I'll call this polynomial f of x. I'm going to evaluate it at these numbers here. So I'll evaluate f of 2 first. F of 2. F of 2 is 6 times 2 to the 4th. Okay? Plus 2 to the 3rd. Minus 8 times 2 squared. Minus 2. Plus 2. Now, if I get a 0 here, then I know that this 2 is going to tell me a little bit about what the factors are, okay? So right now I'm just kind of waiting for a 0. All right, let me zoom in a little bit here. So I now go 2 to the 4th is 2 times 2, which is 4, times another 2, which is 8, times another 16. And 16 times 6 is actually big number. I'll write it over here. 16 times 6 is 36. 96. It seems to be. So I got 96 plus 8 minus 8 times 4. 8 times 4 is 32. Minus 2 plus 2. And so if I were to get a 0 here, then I would know that this 2 here is going to help me get a factor. But, shoot, I don't see that I'm getting a 0. I got 96 plus 8 minus 32. This is not 0. And so, therefore, in the end, we have... we've decided that this 2 is not going to give us a factor. Let me try the 1. So, f of 1, 6 times 1 to the 4th plus 1 to the 3rd minus 8 times 1 squared minus 2 plus 2. Okay, so now this is actually equal to 6 plus 1, 6 plus 1 minus 8 minus 2 plus 2. Okay, 6, 7. Oops, this is actually should be a 1 right there. So this should be a 1, because I'm evaluating the function at 1 this time, not 2. So I get 6 plus 1 is 7. 8, well, actually it looks like, because I got negative 9 and positive 9. So in the end I get 9 minus 9, which is 0. So we have found a 0. What this means is, since I evaluated the function at 1, one of the factors is x minus 1. Okay, so since x minus 1 is a factor, why? Because the factor theorem says that if I evaluate the function at 1 and I get a 0 as the result, then x minus 1 is a factor of the polynomial. That is the factor theorem. All right, so we just succeeded using the factor theorem. Oops. pen's not working. The factor theorem. Okay. Now what we do is, since we found a factor, we must use synthetic division. All right? And synthetic division is covered in the book on page, looking at it right now, page 98. Okay? And so what we do is, if we do it the way that the book looks at it, is, I'll look at here, right in here. Right here they're saying, set up the division. We want to do a factor, let me get this a little bit better here. If we want to take a factor of x minus 2 out of a polynomial, then what I do is I write a little minus 2 right there, and then I'm going to write down the coefficients. 1 is the coefficient here, 2 is the coefficient there, negative 5 is the coefficient there, and 6 is the coefficient there. Alright? Then what you do is you take this 1 and you drop it down like that. And you multiply this negative 2 by this and you write it right there. Then you subtract this. This minus a negative 2 is a 4. And then you drop that down. And you take this, you multiply to here, and then you subtract. Then you write it, then you multiply to here, and then you subtract. So it's the same process. It's over and over and over again. And so it's drop down. Multiply, subtract. Multiply, subtract. Multiply, subtract. Okay? And so let's do that now. I'll explain why we're doing this in a short moment here. Alright? Where are we at? There we go. So we're trying to get a factor of x minus 1 out of this polynomial. And so what I do is I write a negative 1, draw a little line like this, and then I write the coefficients. 6, 1, negative 8, negative 1, and 2. Okay? Then I drop this down for a 6. Then I take this value, multiply it here and there. So a negative 1 times a 6 is a negative 6. Then I subtract. 1 minus a negative 6 is 7. Then I take this and I multiply it here. And so it would be a negative 7. Negative 1 times negative 7. And then I take this and I subtract. A negative 9 minus a negative 7. Remember, minus a negative 7 is plus 7. So a negative 8 minus a negative 7, or negative 8 plus 7, is a negative 1. And I got a negative 1 times negative 1 times negative 1 is a positive 1. Then I subtract here. Negative 1 minus 1 is a negative 2. Then I've got 1 and 2. Negative 1 times a negative 2 is a positive 2. And so a 2 minus a 2 is 0. And sure enough, we got a 0. That is synthetic division. So what that means is I just figured out that x minus 1 is a factor, and the other factor that I'm left with is this right here. It's actually listed right here. X to the third, x squared, x, and then no x. So my other factor happens to be 6x to the third plus 7x squared minus x minus 2. Alright, so I've now just used everything right now. I used the rational root test to figure out the possible rational roots. Then I used the factor theorem to figure out that x minus 1 is a factor. Then I used synthetic division to get rid of the factor. Now what I need to do is I need to basically start the question again and use factor 6x to the third plus 7x minus x minus 2. Now if I factor this one more time, I'm going to get another factor. And so I begin over. Since I already used some of these, I'll try a -1 now. All right. So I've already got my rational roots up here. These rational roots will work for this factor as well. So I used 1 and I used 2. There's a possibility that we could have 1 and 2 again, but I'll just go to another one, -1. So what I'll do is I'll see if f of -1 gives me a 0. If f of -1 gives me a 0, then I'm going to repeat the process. Okay, so I've got 6 times -3, sorry, -1 to the third. This is a -6. 7 is a -7. +1 and a where are we at? -2. Okay, this is a 6 -x -x to the third. Oh, this is supposed to be squared. Sorry, I just kind of messed that up. So notice I had a square here and I forgot to write it, which makes this a +7. And so I end up with a 0. Okay, I was expecting a 0 there. And so look, I've got a 6 and a 2 for a -8, and then a 7 and a 1 for a +8, giving me a 0. So therefore, I see that since I put -1 into my function, that means x plus 1 is a factor. Okay, since f of 1 gave me a 0 over here, x minus 1 is a factor. Since f of -1 down here gives me a 0, then x plus 1 is a factor. And now what I can do is I can pull this out of this polynomial by using, again, synthetic division. So I write +1, since I'm using the +1, just like up here I used the -1 here. Then I write the coefficients. Like up here I wrote the coefficients of the original function, which is up here. Now I'm going to write the coefficients of this function right here. All right? And so my coefficients will be 6, 7, -1, and -2. You must write all of these coefficients. Now I drop the 6. Now 6 times 1 is 6, and now I subtract. 7 minus 6 is 1. 1 times 1 is 1, and I subtract. -1 minus 1 is a -2, and 1 times a -2 is a -2, and I subtract. -2 minus a -2 is 0. And we should be getting zeros on these, which we are. And so therefore my factor is x plus 1 over here. And I'm left with x squared, x, and then nothing. Alright, so it's 6x squared plus x minus 1. 6x squared plus x minus 1. Sorry, 2. Okay, so let me go over this synthetic division again now that I've got 2 here just ready for you. I have my x minus 1 as the factor that I want to pull out due to the factor theorem up here. Then, as I go through and I'm left with these numbers down here, these numbers right here are the other factor that's left over right there. Okay, and you write it down. You start with the third power, second, and then a 0. Why do I know to start with third, second, and first, and so forth? Because my original function was a fourth power. So when I divide out a factor, I'll be left with a third power, because this times this will give me the original fourth power up here. Okay, now that I've taken this smaller third power one and started working on it, I'm left with a second degree function here and a factor right there. And so in the end, my factors are x minus 1. And then this one right here is actually equal to this one. So I'm going to say x plus 1 is another factor. And then 6x squared plus x minus 2. 6x squared plus x minus 2. And now we can easily factor this because it's a trinomial. Factoring trinomials is quite simple. And so we're almost done. I've got one last step I just have to factor this trinomial. And so in the end, this trinomial is going to be 6x squared plus x minus 2. I need two things here and two things here that multiply together. So I'll do 3x and 2x. I'll do a negative negative 1 and a negative 2. Oh, sorry, positive 2. And then this times this is, no, this is not going to work. If I change these two and flip them, I think it's going to work. 3x plus 2, this is not going to work. And 2x minus 1, this is going to work. I got 3x times a negative 1 is a negative 3x. Then a 2x times a 2 is a 4x. Take these and add them together and I get an x. And so my factors are here. And so in the end, the final four factors are x minus 1, x plus 1, 3x plus 2, and the final one is 2x minus 1. I'll write that, 2x minus 1. Okay, and so there we have our fully factored thing. So notice I started with this polynomial. This whole activity here factored out this x minus 1. And this activity down here factored out the x plus 1, leaving me a trinomial, which I factored over here for my final thing there. And I'll just kind of zoom out a little bit so you can kind of see the whole thing. So that would be a fully factored fourth degree polynomial.